Okay, so in the previous class, we had some idea about problem formulation and state space search. As I am telling from the very beginning that the core theoretical concept of AI basically relies on state space search. And state space search means, already we have said, when searches takes place by changing the states from one state to the another state, and that also is achieved with the help of some defined, well-defined actions, because we are talking about who will search in this type of problems. An agent will search, isn't it? So an agent always interacts in the environment, and so whenever I am talking about searching the solution, where? Searching the solution in the environment in which my agent is exposed to, isn't it? So where my agent is situated or actually designed to be in, so that particular environment is actually the environment of that particular agent. An agent searches for the solution in the environment space that we call to be the solution space, and that is also achieved with the help of some what? With the help of some fixed defined actions. Okay, pause for now, as I have mentioned that solution may be anywhere in the environment, and the agent will find for the solution. And what type of solution? Desired solution. So whenever there will be a lot of solutions, all may be promising, but in that case we always go for optimum solution. So these things we have already discussed in my previous class. Now today we will go into much more depth that how my AI agent will start searching for the solution. And what do we mean? We will take some example, real world example. One very interesting example we will take today, that is known as water jug problem, and that problem also came in the semester examination, just immediately took place in the fourth semester examination. There are some well-known problems, like water jug problem that I will discuss today. Another problem that I want any one of you will give a presentation on in the next class, that is the missionaries cannibal problem. Have anyone heard of this? No. Water jug problem, have you heard? No. So I will discuss that, but missionary cannibal problem used to be a computer game, flash-based computer game in our days. So that is a very well-known state space search problem. Now, the main purpose of giving this example will be to get an idea that how a normal problem can be converted to a state space search problem, which is actually basically AI is going to solve. Okay. So, but before I go into the detail, let me tell you that why search is essential in AI. Already I have said that because purpose of AI is to solve some difficult, uncertain, complex tasks which are generally performed by some intelligent beings or intelligent human beings. That is basically the concept. But that is not also always to be intelligent. The works or the tasks or the problems which are very complex in nature, very mundane in nature, very long in nature. So sometimes we also use AI to solve those kinds of problems. Now, basically the main purpose behind that, there are varieties of problems that are being solved by AI nowadays. More or less in every cases we can find that application of AI is well visible. So, but if you think deeply, all of those problems can be converted to a state space search problem, because actually the software or the hardware or the combination which is actually giving you the solution is nothing but an AI agent. So whenever I will be talking about an AI agent, so it is actually interacting with an environment. Environment means from where the data is being given to the AI and based on which AI is actually processing. So indirectly, every problems that are being solved nowadays through AI can be converted into a state space search problem. Okay, so that is why I am talking about searching one is very important. Many examples like route planning, puzzle solving, game playing, robot navigation, so all are basically Then some examples where AI is performing well. More than that is there. So like route planning, puzzle solving, game playing, robot navigation. Other than that, prediction, reasoning. So the application domain is variety, but main types of the problem is more or bit, little bit similar, isn't it? Like route planning may be in our daily life situations, like maybe in autonomous robotics vehicle route planning, it may be, or it may be a Mars rover route planning. So application domain may change, but the work is the planning. The planning of the route through which the agent will move. Simple. Puzzle solving. Puzzle solving is not always now the things is simple puzzles like Rubik cube, 8 puzzles, something like that. But those reasoning or analytical capability of AI can be used also with some extension. A little bit more complex algorithm can be used for theorem proving in mathematics or in physics or in quantum computing, where complex theories are there which need a lot of derivations, experimentation, detailed kind of analysis. Okay, so nowadays, one well-known conjecture was there which has been solved by a famous mathematician. Okay, so which took at least 500 pages to solve that century-old unsolved mathematical problem, but that was solved through 500 problems. But now researchers are thinking, is there any short or algorithmic theorem proving approach? If I give my AI algorithm a sufficient exposure to those type of problem, can that be solved in a little bit more easier or simpler way, or in less steps, something like that? So AI is not limited to this type of robots or something like that. It is also being used in core theoretical research also.
চেঞ্জ বেস বা কোনো একটা ব্রেন সেখানে যারা এআই মডেল যখন আমি যখন খুঁজছিলাম অপোজিট একটা এআই মডেল খুঁজছি, তো ওখানে ওরা এত ভালো কি করে খেলতে পারে যদি ওখানে মানে এত ভালো থিঙ্কিং যে এরপর কি করে ইনস্ট্রাকশনটা হবে বা সেই ইনস্ট্রাকশনটা কি করে ফলো হবে সেখানে মানে আমাকে ডিফেক্ট করছে সেখানে বা আমার যাই হোক সেখানে
see here it is not AI doesn't know about which is bhalo kharab something like that. Try to understand, it has all possible combinations, response to all possible combination and the best response, the optimum response. So whenever any player is taking any move in chess, so what can be the return move? So whenever a human player places a return move, it can think about 2, 3, 4, 5, 7, 6, 8, 10 steps ahead. Those who are expert or grandmasters, they can think far also, suppose 18 or 20 moves. But AI can think about 1,000 moves ahead. What a point. So whenever I have that kind of vision, my approach will be very easy. So there is nothing called about bhalo and kharab. It is only the capability of interpreting each and every move that are being made by human and giving a respond move which should be the most optimum one. That's why only. And obviously, how those base moves are being calculated, there are different algorithms. Different types of algorithms. Unsupervised, supervised, reinforcement. So basically, RL types of algorithms are basically used. Various different types of algorithms are there. But the main motive is that AI can plan further because it has a huge computational capability. But we are efficient, but we do not have that much of vision. We cannot, I am a novice player of chess, I can think maximum 3 to 4 steps. So if I give here this, opponent may give this, then I will give this, then opponent will give this. But after that I cannot visualize. But in the same way, a well-trained AI software can think about hundreds of moves ahead. If this, then that, then that, then that, then that. So it will, whenever it is thinking about 100 chain of moves, and from that 100 chain of moves, it is now calculating which will be the best one now. So that is why it is becoming efficient. Am I clear? So Now the problem formulation already we have discussed. Okay, problem formulation, how to formulate problem in AI, already we have discussed. What are the different stages or steps or components of AI formulation, we have already discussed. Now we will take a very well known example, and this example is being used in the discussion of state space or problem solving many years back. Okay, that is called as water jug problem. Water jug problem, the problem statement is very easy to understand. So the problem, if you search, may come in different varieties or more complexity, but I have taken the simplest example that there are two jugs. One can store a water of capacity 4 liter and another the maximum capacity of 3 liter. Two jugs are there. Okay. Now your target will be, you can perform any possible valid action. Valid action means what? Valid action means either you can fill up the 4 liter jug, you can also fill up the 3 liter jug, you can pour the water or liquid from 3 liter to 4 liter, 4 liter to 3 liter. Got my point? Anytime. So these are possible actions that you can perform. But your target will be perform those sequence of actions. Suppose here 6 actions are mentioned. Check here. Fill 4 liter jug, fill 3 liter jug, empty 4 liter jug, empty 3 liter jug, pour 4 liter to 3 liter and pour 3 liter to 4 liter. Now initially you will be given 2 empty jugs. Now your target will be, you can perform any of these actions in any particular sequence, but at the end your goal will be to keep 2 liters of water in any of the jug. Am I clear? The question is clear. You can perform sequence of moves anyway, any order, but ultimately your goal will be कि किसी भी जग में फाइनली मेरा 2 लीटर वाटर रहेगा, तो वो एश्योर करना है. There is no measuring here. Only you have a jug of 4 liter, another is 3 liter with maximum capacity. Now you can do anything, but ultimately your goal will be to what? Keep 2 liters of water in any of the 4 liter or 3 liter jug. Now this is the problem. Now if I talk about formulate the problem, what will be the initial state? So initial state I have to represent in the form of graph. So if I use the sequence like this, so I can consider a set or something like that, where the first entry will depend the water quantity or the amount of water in the first jug, that is a 4 liter jug, and second was the water quantity in the second jug. So initially 0 0 means both jugs are empty. Okay, now you have to perform different action as you wish, one after another, and your goal will be either 0 2 or 2 0. Getting my point? So your initial state is this, your goal state is either of this. Now actions, what are the possible actions? These are the possible actions. 6 actions you can perform in any order. And if I talk about the cost, cost means more number of steps you are taking to come to your goal. Here that is the cost. Am I clear? Is the problem formulation clear to all of you? So whenever I will represent, so see, I will ask you to make this graph. So initially what I can do one valid move I am saying, that is 4 0. What does this mean? Which action I have taken? Fill 4 liter. Am I clear? Now you tell me, can you tell me now that what is this action? Can I come from here to here? How? 4 to the 3 liter, isn't it? Now in this way you come to the solution. How you can do it? I am giving you 5 minutes. You solve. You solve in a pen and paper. Okay, you have got the solution. Huh? You come here and solve it with the help of mouse. Because that is animated, you can easily do it. So remember the steps. So what you will do? First 3 liter fill. Okay, then 3 to 4 liter. Okay, then did you get? Anyone? Did you get? Now you write down the steps. The state space. Just erase that. If you didn't understand, I will ask Abhishek to repeat this. Abhishek, reset the problem and again start.
First, we will fill 3 here first. So, 0. First, we will start with 0, 0. Okay. We will move on to 0, 3. We have 3 liter. Now we will transfer the 3 liter to 4 liter. So we will have 1 liter of space in 4 liters. So 3, 0. Then we will fill the 3 liters up again. So we are moving to 3, 3. We have 3 liters in both of the containers. Okay. We have 1 liter space in 4 liters and we have 3 liters in 3 liters. So if we remove 1 liter from there and put it in 4 liters, then we have 2 liters in 3 liters. So we move on 4, 2. Now we can either keep it here or we can remove the 4 liter as well. We go to 0,
Did you get? Now do one thing, Abhishek. You just name the actions A1, A2, A3, and in the edges you write down the actions. Suppose name. You just give the name of these actions as A1, A2. Okay. Then you in the edge you write down the actions that you have taken.
First, initial state, we will fill 3 liters. So A2. We will move on to pouring 3 liters to 4 liters. Same things. And then we will go. We will fill the 3 liters again. So we will go to A2. We will go 3 liters to 4 liters again. So same things. And then we will add to the 4 liters that is
A1, huh? Empty the folder. Okay, A3. Okay, good, very good. Thank you. Sit down. Okay, if anyone has any other solution, see, it can be achieved in other ways as well. So if anyone has any other solution in your mind, it may be long or something like that. But if anyone have any other solution, they can tell me. So now, did you understand that how a problem can be converted to a formal structure, that is problem formulation in AI with the help of state space? So these are actually the states, isn't it? So this is my start state and this is my goal state, isn't it? Now I can reach my goal state from the starting state through some various intermediate steps. But those changes can be achieved only through some valid sequence of moves or actions. Not arbitrary, but valid sequence. Am I clear? So, this is how the problem is solved. A very basic example, but the whole idea can be understood from this example. So anyone else have got any other solution? Think. I am giving you a few minutes. Didn't get any solution? Okay, let us try. First, fill 4 liter. Then from 4 liter to 3 liter. How much? Then empty 3 liter. Then 4 to 3. Then again 3 to okay, fill the 4 liter, now fill the 4 liter and then 4 to 3. So it is now 2 liter. This is also a solution. This is also a solution. Na? So here I have reached 2 0, not 0 2. Now you can empty 3. Got it or not? So what can anyone remember? So let us try this solution again. Bolo? Fill 4 liter. Then you draw the state space. You draw the state space on your copy, what I'm telling. So then 4 to 3. Then empty 3. Then 4 to 3. Then fill the 4 liter. So here now it is 2 liter space is there. So then again 4 to 3. Then empty 3. So this is also a solution. But if I talk about optimum, so less number of steps. So if you talk about less number of steps, then the previous one was taking the less number of steps. Got my point? Now, if I talk about the search tree means all possible moves. So, why search tree? Because how AI solves. Now, we are doing a lot of calculations here, but we are not about sure that how my algorithm is working. We are based on our own intelligence and intuition, we are giving the solution to this. But maybe indirectly in hidden in our intelligence, some algorithm is working, but it may be a mixed combination hybrid of algorithms that we are not able to quantify how I have done this. If I ask you that what was your steps in coming to this idea, as Abhishek has given the first solution. So if I ask, just note down the steps, how you have come to the idea, he won't be able to write it properly because it just came through intuition, because as per our experience and intelligence. But we cannot write a code, we cannot define an algorithm for a computer and a machine for which we do not know about the steps. So how the AI things works to get the solution. So basically all these agents, all these agents, what do? We first develop a search tree. Search tree means all with all possible moves. So I am giving you the some depth of this search tree. So initially it is 0, 0. So what can be, how many steps can come from this first two step? Either it can be 4, 0 or it can be 0, 3. Isn't it? Now from this 4, 0, what can be the different steps? It can come 1, 3, then 0, 0 means previous one, I am not giving it, and 4, 3, anything else? Anything else from this? देखो now, all of you check. Now from here, what can be the possible actions? 4, 3, then 3, 0. How? 3, 0. Any other steps possible? Now from 1, 3, 1, 3. Then it comes 4, 3. 1, 3 means it can come 0, 3. Then 1, 0. Anything else? 4, 0. How? Acha. 4, 0. So I'm coming, so I'm not taking it. Anything else? Okay. Now from here, 0, 3. 4, 0 is already there. Anything else? So just to keep the level, I am writing here. So it is কোনটা বলেছিলে এখান থেকে 0, 3 to 0, 3. Now from 1, 0, come here. From here, what I can do? 4, 0 and 0, 3 is already there. Are you missing any steps? আমরা ওখানে কি করছিলাম? Whenever you were doing, first we are filling the 3 liter, then 3 to 4. So 3 to 4 state I have written here. Have you written here? 3 to 4. Which one is 3 to 4? After 3 to 4 minutes is 4, 0. So this situation is not there. So here should be another steps. No. Whenever you were doing, so 3 to, initially what you were doing, just check me this state. Abhishek, that has done. So first we had done this. Then, so this is 0, 3. So I am coming here. And then what are you doing? Fill 4. 3 to 4. So this is 3, 0 means this one. So from 3, 0, how many different situations I can come? 3, 3. 3, 3 or 3, 4. 3, 4 how? 3, 0. 4, 0 how? If 4, 0 means Okay, 4,0 you can give. Anything else? So now here what you are doing? You are again filling the 3-liter jug, isn't it? So 30 from 3, where is 30? So 30 you can do 3, this one. So you are doing 3. Now from 3, then you are emptying all the, then 3 to 4. So 3 to 4, 3 there. So from 3 what I can do? I can come 4 to 4 state I can come. So from 4 to I can reach to. So one thing you understand, the solution is there in the search tree. But what we were doing, we were coming to that our desired path very quickly based on our own intelligence and intuition. But if someone gives you this whole tree, then you can easily identify the node. Am I clear or not? Then to identify node, you can find the path. So here you can easily understand and check that. I can easily understand and check that this is my path to the solution. Are you getting or not? So if your search tree is there, suppose I do not have that much intelligence of finding that, or I do not have the intelligence of like this problem. I have only this search tree and I have asked someone to find out the 0, 2. Are you getting it or not? So what the person will do if he does not have any knowledge of the search tree, how long it is, how depth it is, how vast it is, no. So what it will do, what he or she will do, it will start from checking from the root node. Problem check over there, where is 0, 2 or 2, 0? This is my desire. So I will check, is it 0, 2? No. Is it? No. Is it? No. Now check, is it? Is it? No. 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 Now I am coming here. Is it? Is it? Is it? Is it? Is it? Is it? No. Now I am coming here also. No. Okay, now I have got it. So this is one of the simplest way to search. Where my solution is, I do not bother what water jug problem is. Because the computer algorithm will not know about water or jug. It only understands the numeric values of the solution. So I have told you that your start is 0, 0 and your goal is to find the 0, 2. Now how it will search? That is actually called the search strategy. So if the whole search tree is there and if I ask my algorithm or my agent to search that search tree, it has to follow a what? Strategy or a process like that. Whatever I have applied this search, what I have done? I have checked each level of the tree one by one. Each level means breadth wise I have searched. So that's because this search that I have told you is known as breadth first search or BFS. Understood? Now suppose if my search was like this, okay, this is very high, I will come here, okay, now 0, 0 solution, no, 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 pelam na. So here I have last depth পর্যন্ত নিয়ে গেছি, if solution is not, then again I will do check here, no. So if I check the solution depth wise, mean first I will follow a particular direction until and I am reaching the depth, last depth, the deepest level. I continue search, but whenever I am got the deepest level but still didn't get the solution, then what I will do? I will backtrack and then the previous, then again come to the depth. So in this way, so whenever my priority or the precedence is to go for the depth first, then the breadth, it is known as depth first search. Simple. I think you have heard about BFS and DFS, but how it is actually applied. See, when I told you I have this breathwise search, you understood this, but at that time you didn't know that you were learning the DFS. Got my point? So in our daily life also in many types we apply all these algorithms, but we never concentrate on those algorithmic name or strategies. जरूरत नहीं है. Those who do not know BFS, they also use BFS. Those who do not know divide and conquer, they also do know divide and conquer. Rather the farmers also, whenever they plug the field, they also apply divide and conquer in many cases, but they do not know. If you go there and ask them, okay, you are cultivating the land, very good, come with a pen and paper. I will make you understand about the strategy you are following, how you can make it further. They don't bother. But they are also applying, either backtracking they are applying, or divide and conquer they are applying, or greedy they are applying. Greedy search, you might have heard that also. Whenever you go to the invitation party, you do go for greedy. If you are very hungry, what do you do? First counter में जाके जो अच्छा खाना दिखता पेट भर के खा लेते हो. But that doesn't guarantee you that that is the best food, because वहां पर बहुत सारे हैं अभी, लेकिन आपको भूख मिला था, आप वहां पर गया, स्टार्टर में कुछ चिकन पकौड़ा आपने देखा और पूरा एकदम पेट भर के खा लिया. So at that time that is also greedy solution, because best solution is not that. Initially जो आपको अच्छा लगा सबसे, you have done that. Whenever you enter into a crowded bus or train, you search for seat. That is also a greedy search. जहां पर भी खाली दिखा बैठ गए, फिर जाके इधर उधर देखा, अच्छा इससे अच्छा कहीं सीट है, विंडो वाला मिलता तो अच्छा होता. तो इनिशियली जो सीट लिया, that is actually greedy approach. But whenever if you check all the seats and all, then the best one, that is a different approach. And also whenever you enter into the middle part of the compartment, either you go to the left or to the right, divide and conquer. So in many cases in our daily life we apply a lot of searches, but we didn't focus that this is the name of an algorithm. But whenever we have to code an AI agent, we need a formal description and definition that I will discuss. Okay, so is it clear now? The discussion that we have done so far, is it clear? Any doubt? Any doubt? You can ask question before I move on to the next part. Last bench. বুঝেছো? হ্যাঁ? বোঝাচ্ছিলে? কি বোঝাচ্ছিলে? কোন? এখন কি কোর্স করতে হবে না করতে, কিসের জন্য? এআই এর জন্য? কেন হঠাৎ কোর্স করতে হবে কেন মনে হলো? এমআর পয়েন্টস এখন এসব ডিসকাস করার সময় তোমার? ওকে, now one thing is very clear. So whenever I have Abhishek, look at here. So once we have developed the search tree, now I have got my full state space. Now I have to search in that state space. So now we are moving to that great depth to the state space search. Now you have understood that all possible search problem I can represent in the form of a graph, state space graph. अभी वाटर जग को हमने बना दिया. So in this way I can टिक टैक के बारे में बताया था. So that can also be represented in the form of state space graph. So normally any state space graph there are 4 different types of symbols: nodes, that actually problem configuration, there is the states, as you know. Then the ages define the actions. I asked Abhishek to mark the ages that which action it is performing. Okay. Then a goal node will be there, that is also a subset of the all possible sets and states. And the initial node, that is the starting node, which is also a subset of the all possible states. Clear? So there are these four components. So with the help of these four components, we will develop a search tree or a graph. And now in that graph, we will follow some strategy, apply some technique. Without technique, that is random. Random means there is no clue whether I will be getting to the solution or not. There is no means. Getting it or not? So normally two types of search, all the AI search techniques, hey, listen, all the AI search techniques are categorized into two parts. What are the two parts? It is written there. What are those? Uninformed and informed. The many clue or the major clue is given in the name itself. Uninformed means what? Suppose someone is coming from the outside and he has asked to go to the AIML third semester classroom. Okay. This is one scenario. And another scenario, another student or another boy or a girl is also asked to go to the third semester AIML class, but he said that third semester AIML class may occur in the main building, probably in the second or third floor. Now see whose search will be easier. Why? Very good. Means before starting he has got some information about where my solution can be. Is it? But in the first case, he does not have any information where the solution is. He has to search the whole campus. That means in the first case, the agent was not informed about the search space. I mean, had no clue or no guidance at all about the search. That means whatever he has to do, he will search blindly. So that is why this type of search are known as uninformed or blind search. Like the example that I have given, the BFS and DFS. Did I give it any information about where my solution state is there, 20 or 02? Did I have any information initially? No. What I used to do? I was following a proper strategy. So the strategy was not dependent on where the goal state is. But strategy was such that if there is a goal state, I will be able to find. That is the strategy, na? So in that case, the agent didn't have any information about the search space. So that is why it is known as uninformed. Is it or not? Okay. Now in some cases, agent have some information about the search space. See, it is not information about the search space does not mean I know where the solution is. If I know where the solution is, then what is the requirement of searching? दोनों में confuse मत हो जाओ. Information about the search space, not the information about the where the solution is. That means what? It is some kind of a concept or idea or calculation. Normally, those who have visited Kolkata, there is a big tower, very thin, big tower is there which can be seen from Dharmotala or Esplanade. What is the name of the tower? D42. उसका और एक भी एक नाम है. Have you seen? The tower is not very large, very thin but tall. ধর্মতলাতে তো নয়, ওটা কোথায়? পার্ক স্ট্রিটের ওই দিক থেকে দেখা যায়, বিকজ হ্যাঁ আচ্ছা, নাও সি, হ্যাঁ 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 D42, good. Now see, that tower can be seen from 10-kilometer radius anywhere, or 5-kilometer radius from anywhere. Try to understand. Now if I have to go to a office to that tower, I cannot go straightly because there is no path. So suppose from Dharmotala I do not know path, how to reach there, but you have to go there. So what should be your strategy? What you will do? You will follow a path, maybe randomly or something like that thing. Then after time you will check whether I am coming towards the tower or I am going far. So if I am going far, that means I am not in a proper direction. If I am coming closer, then I am the right direction generally. So after each 10 minutes, I will check my straight line distance between me and my goal, that is the tower. So if that straight line distance is reducing, that means I am coming closer. So in this way, finally I will be coming to a solution. Is it or not? This is a normal approach. But more interestingly, do you know, this is actually an informed search strategy. And AI, it is known as heuristic search. That straight line distance is giving you a extra input to the solution space that you are using, that are actually helping you to find an efficient solution. So whenever my agent will get such a function or such a mathematical tool or a calculation which will guide it whether it is coming towards the solution or going further from the solution, this will call as a informed search. Did you get the difference between informed and uninformed? Any clue, any question or any doubt?
স্যার যদি আমরা এটা একটা ট্রেনের কামরার এক্সাম্পল নিই, যে কোনো দুজন প্যাসেঞ্জার, একজন অলরেডি রিজার্ভেশন করে গেছে, আরেকজন রিজার্ভেশন করেনি, তাকে জেনারেল কামরাতে যেতে হচ্ছে। তো এবারে
Hey, all of you listen. Hey, why are you talking?
স্যার যে রিজার্ভেশন করে গেছে সে তার জানে যে তার কামরাটা কোথায় আছে, সে ওইখানেই যাবে। বাট সে যে জেনারেল কামরাতে যাচ্ছে সে জানে না যে সে সিট পাবে কিনা, তাহলে তাকে গিয়ে সার্চ করতে হবে সমস্ত কামরাগুলো জেনারেল কামরার মধ্যে। তো সেটা কি ধরনের সার্চ? ওটা কি গ্রিডি বেস সার্চ?
দেখো, greedy, these are different types of categorization, greedy, divide and conquer, but this is actually based on my knowledge about the search space. So if a person has not any reservation in any of the 10 compartment, then it will be an uninformed search, but always also not uninformed. Why? Because he knows where the general compartments are there. If he also have no information about where the general compartment is, it can be any of those 17 coaches, then he will start from one side and gradually move to the next side. So that is a blind search. But if he knows that general compartments are there, first two coaches in the first initial portion of the train and other two coaches are last, so then that is not a blind search, that is informed, because that information about the train structure is there. But he will not search in between, na? और जो आपका रिजर्व वाला है वो तो इन्फॉर्म्ड ही है, क्योंकि ही विल गो हैं।
little bit of information is needed for information search. अगर কিছু ইনফরমেশন নেই তো মানে ওটা
ब्लाइंड।
বাট সে ওই কামরার মধ্যে সিট পাবে কি পাবে না সেটা তো আনইনফর্মড।
পাবে কি পাবে না, that is due to the uncertainty. Try to understand. If there is a seat, then he will get. So if there is no seat, he will not get. Simple. So it is, if solution exists, then he will get the seat. Again, whenever he enters the compartment, again he will search. How the search will be?
Then it is uninformed.
Uninformed, he will just check gradually. ও কি খুঁজবে না, চোখ খুঁজবে ওর। So whenever either check করবে or something like that, or in this way, so whenever it will get, you proceed it. So basically, whenever the agent does not have any information about the search space, then it is known as uninformed search or blind. Blind মানে বুঝতেই পারছো। And when the agent has some information means some knowledge about whether it is going towards the search solution or going away. So that then it is known as informed search or heuristic that I will come. So already you will go through this, but still I am briefly discussing today. That is in uninformed search. Basically, we discuss different searches like breadth first search. Already I have said. Depth first search. Already I have said. Then depth limited search is there. DFS with iterative deepening. Then uniform cost search. So all are basically modification of this BFS and DFS. You can consider extension modification. Preliminary to search, that is BFS and DFS. So very quickly I will say, because you will understand this. And about the informed search, you can see later. I am discussing about the BFS. Already I have said that BFS is breadth first search. Means it will search level wise. First check the root, then the first level. If my solution is there, okay. If not, go to the second level. If the solution is there, it's okay. If not, go to the third level. So in this way it will continue. Got my point? So the algorithm is start with initial state in queue. So whenever we search, because the nodes is a node that I have to keep track of. So we need a storage structure to store the information about the nodes that already we have visited or we are going to visit. Visit means whenever we have come to a node, we call that node to have visited. But whenever I am in a node and I can see my neighbor nodes, like from this A, B and C are my neighbor nodes. So actually connections here didn't come. The connections are like this. So whenever I have in A and I have seen that from A I can go to B and C. So it is code that I have explored B and C, but I have not visited it. So when I will come to B, I will say that is visited. Now in BFS or DFS, what I will search, I will change my node to node, my position from one node to another node. That means I will change my state from one state to the another state. So the state information are generally stored in some storage structure. For BFS, that storage structure is known as queue. That you are learning as data structure, you will learn it. And for DFS, we actually use stack. But the idea is very, very simple. So algorithm steps start with the initial queue, and you know that in a queue, the push pop. So it is a FIFO concept it used. First in, first out. The element which is entered first will be popped first. Is it or not? Now queue also. So remove the first node from the queue. Check it whether it is a goal state or not. If it is goal state, then it is okay. If not, then again search is neighbor node, and in this it continues. Very easy. Now here initially I have. So A is my start node. So if I start my BFS, so I will initially search my start node and I will push rather NQ all the neighboring node of A. What are the neighboring node of A? B and C. So you see in the queue B and C is inserted. Is it or not? Then I will, next step is what? Remove the first node from the queue. So what is the first node? B. So B came first, so B will be popped up, and on the B will check whether B is a goal node or not. So if B is a goal node is good, but here in the case goal node is F. So B is not the solution. So B ka jo, what is that? Neighbor node hai, that will come, that is D and F. So D and F will come and sit beside C and beside C. So in the next what will happen? D and E is inserted into the queue after C because it is queue na. So it will end में जाएगा. First जो आया तो first निकलेगा. तो डी और ई से पहले सी आया था, तो अब क्या होगा नेक्स्ट, इट विल चेक द व्हाट, सी इज माई गोल स्टेट, नो, तो सी पॉप हो जाएगा और क्या आएगा एफ एन, ओके. Now the D is visited, at the same time D is visited, but D is not a pop and D is not a goal state. দুটো click হয়ে গেছে আমার, so that's why it's English. But now D is not the solution, D is pop. Now it is coming E, so E is the solution. No, और neighbor node भी नहीं है, so E simply pop हो जाएगा. Now कौन आएगा F. So whenever it will check F, whether F is my goal, yes. So when F is my goal, then it will say that goal is found. Easy na? It's very easy. Now in the next class, here you can see all the steps. In the next class I will discuss about the DFS, okay, and then compare between the efficiency of BFS and DFS, which is very important. And also all algorithms have their own merits and demerits, you know, and all algorithms have their problems also, कि कौन सा problem के लिए कौन सा algorithm suitable होगा. और आप लोगों के लिए आज के दिन में that is the important, मैं शुरू में बोल रहा था ना कि now solution can be easily generated by AI. If you ask AI to write a code for any particular algorithm, it will write it. But which algorithm you will select for which particular problem, there you need your intelligence or expertise. Okay, so any question or doubt so far? Any clarification you need? So what we have discussed, any terms that we have learned today? यूनिक टर्म बोलो, कोई एक एक करके बोलो, एक स्टूडेंट एक टर्म. হিউরিস্টিক সার্চ, বিএফএস, ডিএফএস, ওই দিক থেকে ওয়ান বাই ওয়ান একজন একটাই বলবে. ওয়াটার জাগ প্রবলেম কি, ট্রি সার্চ, গ্রিডি সার্চ না ট্রি সার্চ কি বললে, গ্রিডি, ওকে গ্রিডি, এইদিকে বলো কেউ. স্টেট স্পেস যদিও আগের দিনে বলা হয়েছিল তাও হলো. এনিথিং এলস? হ্যাঁ, সার্চ স্পেস, সার্চ ট্রি ও তো বললো কে একজন. এনিথিং এলস? uninformed and blind. हाँ वही একই হলো. FIFO, FIFO. Okay, very good. So if you just recollect in the evening these topics, you can easily remember the whole class, because human brain is sufficiently clever. If you know the nodes na, so connection will automatically come. So if you remember the FIFO and search tree, these two words, automatically how FIFO is applied in search tree, automatically your brain will remember. So I always focus on the topics. Keep the topics in your brain and think all the connections will be automatically done and you recollect the whole class. ठीक है? Okay, turn up. हम दे देंगे.